All right, guys, we continue on chapter 6 with our third part of the video notes, which talks about law of cosines. So in class and previous videos, we've talked about solving oblique triangles, non-right triangles, using law of sines. That would be necessary in an angle-angle side case, an angle-side-angle case, or the ambiguous case, a side-side angle case. Okay. The other two cases, if we think back to geometry again, would be the side angle side or side 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 case. So if we're given two pairs of sides and the angle in between, the included angle, law of cosines would help us solve for the triangle, the missing lengths and angles. If we were given all three sides of the triangle, we could use law of cosines to solve for the missing angles. We'd only really need to solve for two of them using law of cosines, find the third very easily. Okay, so I guess I should have written that down here. Side angle, side, 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 side. So in one of these two situations, if we're given, that would be the side angle side case. This would be the side 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 case. We could solve these triangles using the law of cosines. Now, just like law of sines, when you see it in a textbook and when you see it in math, it's written three different ways, okay? But what I'd like to do is generalize this law of cosines formula to really identify which parts of this should come from which parts of the triangle, okay? So remember, our lowercase letters are going to be the side lengths. Our capital letters in trigonometry, and when we talk about triangles and trig, are angle measures, okay? So as you can see, the first part of this, I kind of think of it as two different parts, okay? Now we're going to give you this formula when we end up getting to the quiz. I mean, it's remote learning, okay? But what you should see is the bookends. The side length solo on the left side of the equal sign matches with its opposite angle, okay? So those two kind of bookend the law of sines. Sorry, the law of cosines. So we have angle A, or an angle of the triangle, and its opposite side. They would go in the cosine parentheses and solo on the other side of the equal sign. The rest of the information you would have to input are the other two side lengths. Okay. So we have the angle that we're working with. We're only working with one angle anytime we use law of cosines, whether it's the given angle or one that we're solving for. All right. Its opposite side goes on the other side of the equal sign, and then in the middle here, with the cosine of A, we're going to have the other two sides. Square both, put a plus sign in between them, minus 2, and then, again, those other two side lengths. Okay? This would be the angle we're working with, and its opposite side. And then those other two side lengths would make up the rest of the law of cosines. All right, so here's what we're going to do. We're going to do an example so you guys can see exactly how this is going to work. Use the law of cosines to solve this triangle. As always, we'll label these ABC. I did have a student in my class ask if the drawings, how accurate they might be matter. I would probably draw all of my triangles to look like this. I know C right here is probably not 28 degrees, but doesn't really matter for the purpose of solving these triangles. So we've got 28 degrees for angle C. The side length across from A is 4 inches. The side length across from B is 6 inches. This happens to be a side angle side case, meaning we should use law of cosines. Now let's say you forget that a side angle side case here, given information, should lead us to the law of cosines, and you tried to use the law of sines. It's not going to work. You don't have this angle's opposite side. You don't have this side's opposite angle. You don't have this side's opposite angle. So no matter how you set up the law of sines proportion, you're going to end up with two unknown things. That's no good. Okay? If that happens, what should click in your head is, oh, I forgot. I should be using law of cosines here. Okay? All right. So I'm going to rewrite the law of cosines as it's written above down here so we can talk about. Okay. Now remember, I'm not a big fan of using these letters. Okay. If we wanted to, we could use the third one down where it had angle C. But I do want to talk about, because we try not to rely on memorization as much as possible. Okay, so we're going to input values for each of these variables here. Okay, where I would start using law of cosines is by identifying what angle will be part of this formula, and then its opposite side. That angle's opposite side. The only angle we're given here is the 28-degree angle. So we have to use that one. Its opposite side is actually the one we don't know. If you want to give it a new variable like x, feel free. I'm just going to call it little c. All right. And then our other two sides will make up these. That's how we kind of define that, generally speaking. Okay. So our other two sides would be 4, 6, 4, 6. Notice it doesn't matter in which order you write them, because when we add these, 6 squared plus 4 squared, that's going to be the same. 2 times 4 times 6 is the same as 2 times 6 times 4. Okay, so this is my attempt as for having you not memorize the law of cosines in a way, but understand that the angle and its opposite side would be the bookends here, and in the middle we would have those other two side lengths. All right. If you really want to, knowing that we're going to use angle C, if you want to kind of write it as the third one and be very specific about the fact that A and B actually do represent little a and little b here, and angle C, that's fine. Okay. You know, as a teacher and somebody who's used law of cosines a little bit and understands it, I don't really need to do that. What I do need to do is solve for C here. Okay. Side length C. Now we could do all this by hand, or you could literally type this into your calculator with a square root. Why a square root? Because we don't want to solve for C squared. We want to solve for C. Okay. And what you should see is we will get 3.1. Round to the nearest tenth. It'll be 3.1 inches. It's one of the things that we have to solve for. Okay. What we're going to do here, now that we know this is 3.1, which makes sense, this is a very small angle. Okay, let's pick out one of these other angles to work with and solve using law of cosines again. Okay, so let's choose angle B to solve for. All right, so if we're looking for angle B, that's going to be our unknown. Okay, so we're working over here. This is how we're going to solve for angle B. Now remember, the angle and its opposite side would be with the cosine and then on the other side of the equal sign. The opposite side from angle B is 6. The other two sides are now 3.1 and 4. I'm going to run out of room here. Minus 2 times 3.1 times 4, cosine of B. The algebra here is going to be harder than what we just did. Okay? We're solving for a variable that's in a trig function. So we're going to need to think back to how we get this trig function by itself. Then we're going to have to use the inverse trig function. So let's do that here. 6 squared is 36. All right, 3.1 squared is 9.61 plus 16 minus 2 times 3.1 times 4 is 24.8 cosine of B. All right. Now, we have a lot of students that like to break algebra rules here, okay? We cannot, first of all, let's add these two together. 36 equals 25.61 minus 24.8 cosine of B. A lot of students want to subtract these two numbers. These are not like terms. This has a cosine of B, this does not. So what do we have to do? Subtract 25.61 from both sides. we'll get 10.39 equals negative 24.8 cosine of b. Still looking to get cosine of b by itself. How do I want to do that? Divide by negative 24.8. Divide by negative 24.8. If we put that into our calculator, we'll get negative 0.418952. We can use all of the decimal points because this is not a final answer for us. Now that we've gotten our cosine of b by itself, we'll do inverse cosine of negative 0.418952. That's going to equal angle B. We'll type that into calculator. Make sure you're in degree mode as always, which means angle B will be 114.77 degrees. Not a lot of work needed to find that last angle. Angle A will be 180 minus 142.77. I believe that's 37.23 degrees. All right. So we used law of cosines to find a side length in this problem. We used law of cosines to find an angle in this problem. That should be enough examples for you to be able to use that as a model to repeat that when needed during this chapter. Okay. The algebra, much tougher here when we're solving for an angle. Okay, please, please, please do not combine these two terms. You know, once you square one of the other sides, we add them together. In this case, we got 25.61. We got to avoid the temptation of subtracting these two numbers. Okay? If you do that, many times when you try to finish out this problem using inverse cosine, you're going to get an error. If that happens, please look back at your algebra here. Okay? We'll practice this a little bit during this week, and then you guys will be ready to go for our law of sines and cosines quiz. Okay? So, recapping. We use law of cosines in a side angle side or a side case. If it's side angle side, we would solve for a side length first, like we did in our example, and then solve for one of the two missing angles, both using law of cosines. Find the third by subtracting the other two from 180. If it was a side case, we would have to instantly begin by solving for one of the angle measures using law of cosines. We'd then solve for one of the other two angles using law of cosines. Find the third by subtracting those two from 180. Generally speaking, the law of cosines, to set up the law of cosines, the angle we're working with goes with the cosine. The side length opposite from that angle is SOLO, squared on the other side, and then the other two side lengths represent what's happening kind of in the middle. That's how I think about it. If you want to memorize all three of these and be very specific, that's fine, but I don't want you to get confused if we give you triangle DEF. Okay? There are no D's, E's, and F's here, which is why we talked about it as a general formula here. What parts are represented in this one formula. That's the way I'd like you guys to think about it. And we're good for law of cosines.